Hello, my name is Darren Healy. I'm a doctoral researcher at the University of Eastern Finland, and I'm here today to present our work on the development of a composite exposure exposome score. So the exposome tries to capture all the different things you're exposed to. These can be environmental exposures such as air pollution, temperature, green spaces, but also lifestyle exposures such as diet quality. Are you exposed to smoking? How is your sleep? And it tries to capture the effect of these across the different life stages of an individual. The primary focus of my doctoral research is to investigate the relationship between diet and air pollution and its impact on cardiometabolic health. Recently, we found that diet quality modified associations of air pollutants with cardiometabolic outcomes. In individuals with a high diet quality, we found that total cholesterol wasn't seen to increase with exposure to air pollution. However, total cholesterol did increase in individuals with a low diet quality. So given that we've seen this interaction between diet and air pollution, we wanted to do a follow-up study to try capture the overall effect of multiple exposures and to see if this provided any added value to just measuring the individual exposures themselves. To do this, we used a scoring approach. Scoring approaches have been used in other fields of research already, such as in nutrition, where we have the Mediterranean diet score, the Baltic Sea diet score, etc., but also in trying to calculate the risk of disease, such as the cardiovascular disease risk score and the biological health score. So to assess the value of an exposome score, we use the PANIC study, which is a physical activity and nutrition intervention in children, and we created an exposome score based on the data available in this study. So what we did was we calculated scores for various different categories, and then we added all these scores together to have a composite exposure score. And we investigated the association of this exposome score with metabolomics in the PANIC study. We used both LCMS and NMR metabolomics to try capture the overall picture of the exposome score. So the 5 categories that were used in this exposome score were diet quality, physical activity, that included both total physical activity, but also sedentary time. We had a measure for sleep, we had an air pollution category, and we also incorporated socioeconomic status. So the first objective was to investigate the exposome score itself and compare this to the individual exposures to see if the exposome score provided any added or unique insights. So what we found was that the exposome score was associated with 31 metabolites. And of these 31 metabolites, 12 were unique associations. This means that these associations were only found with the exposome score, but they were not found with any of the individual exposure categories. Furthermore, we found out that there were 95 metabolites that were significantly associated with one or more of the individual exposures, but not the overall exposome score itself. In some cases, these metabolites were associated with 3 or 4 of the 5 categories, but not with the exposome score. And when we looked at these in more detail, it seemed that the direction of the effects contrasted with each other, and when you combine them, it led to a neutral overall effect. We also explored the potential role of adiposity as an effect modifier. And so to do this, we used body mass index standardized for age and sex. And what we found was that BMI modified the association of the exposome score for 31 metabolites. These were primarily metabolites associated with increased cardiometabolic risk, such as branched-chain amino acids, creatinine, and glycoprotein acetals. So to show what this may look like, we're going to use the glycoprotein acetals as an example. Now, these glycoprotein acetals are a kind of novel inflammatory biomarker of early cardiovascular risk in young people. And so what we see here is that in the individuals with a lower BMI, the glycoprotein acetals don't seem to increase even with a higher exposome score, which indicates an unhealthier exposure profile. However, in the individuals with a higher BMI, with an unhealthier exposure profile, we do see an increased concentration of glycoprotein acetals, perhaps indicating that an unhealthier overall exposure profile increases the risk of cardiovascular disease. We also were interested to see if there was a specific exposure that was having a major effect on the overall exposome profile. So to do this, we conducted a leave-out analysis. And what this includes is rerunning the analyses and each time removing one of the exposure categories. For example, we may remove diet quality from the exposome score and then run all of the analyses. And then we would put diet score back and remove physical activity and then run all the analyses again. And we would do this for each of the individual exposure categories to see if any of them were having a major contributing effect on the overall exposome score itself. So what we see here in the bottom left is the overall number of associations with both the original exposome score, but also each of the leave-out models. And so what we see here is that the original exposome score has more associations than most of the other leave-out models, with the one exception being air pollution. So when we've removed air pollution from the exposome score, we've seen a larger number of associations. And when we looked into this in more detail, we've seen that air pollution was having an opposite effect compared to some of the other unhealthy exposures. So for example, an unhealthy diet or unhealthy physical activity score may increase a certain metabolite, whereas air pollution was showing a decrease in that metabolite. We also wanted to carry out a few methodological analyses to determine the feasibility of the score, but also to try assess what other considerations should be considered in the future to further refine the exposome score and improve its applicability and generalizability. So the first thing we did was we wanted to explore the interactions between the individual exposures. I mentioned at the start of the presentation that we had previously found an interaction between diet and air pollution, and we wanted to see if there was interaction between other exposures here as well. And to assess this, we used, again, glycoprotein acetyls as a test case. And what we found was that every single combination of exposures had a significant interaction. So like we found previously, here also we've seen a significant interaction between air pollution and diet, but we also see significant interaction between diet and sleep, and a significant interaction between physical activity and socioeconomic status. So the next thing we did was also to assess the impact of different measurement tools. And in this case, we just chose one exposure category. In our case, we had diet category, and we wanted to test the impact of using different validated diet quality metrics. So what we did was we computed the exposome score with a different diet score for the diet category each time. So the original used the Finnish Children Healthy Eating Index, but then we also conducted analysis with the exposome score using the Baltic Sea diet score and the Mediterranean diet score to see if the results were similar or not. And what we've seen is that while there is a little bit of overlap, there's also quite a lot of differences in the findings depending on which diet score you use. Interestingly, when we compared two metrics that are validated in the Finnish population, the Finnish Healthy Eating Index and the Baltic Sea diet score, only a third of these results overlapped. So even though these are both validated in the Finnish population and we carry this out in the Finnish population, the results differ quite a bit depending on which measurement tool you're using. So while there are some challenges to using or developing an exposome score, we did find that there were some perhaps added value to using it. And so what we're doing next to test its feasibility and perhaps improve its use. Firstly, we have this cross-EU project collaboration with Equalife, which is a similar exposome project, but looking at the impact of the exposome on mental health and cognition. And so we want to test and validate the exposome score in different populations. We are using the Walnut study and the ABCD study, which are both carried out in young people. Walnuts is carried out in adolescents, and we are using the childhood phase of the ABCD study to see if the results can be validated, but also if there's any region-specific differences in the exposome score that might alter the impact of the findings. It would also be interesting to investigate the exposome score in an adult cohort, and on that basis to try use a more fixed endpoint. Metabolomics is quite sensitive and variable and can change quite a lot. And so it would be interesting to assess the feasibility of an exposome score with a more fixed endpoint, such as some lipid measures or glucose, or even cardiovascular disease incidence or mortality, for example, to see if it actually shows a relationship, and to see if this exposome score provides added values to measuring exposure profiles and disease risk compared to just the individual exposure measurements themselves. And then also we will continue with our primary focus, which is the interaction between lifestyle exposures and environmental exposures, to see if we can manipulate the lifestyle in some way to try protect against the impact of unhealthy environmental exposures. So to wrap up, we found that the exposome score may have value in identifying unique associations or providing added insights. However, not necessarily to replace the individual exposures, but in addition to the individual exposures, to both investigate the individual impact, but also then try to assess its role in the overall kind of combined impact. We also consider the feasibility of a universal exposome score. For example, we calculate a very simple exposome score, but we've shown that there's interactions between all the different exposure categories, and we didn't model these interactions in our score, so that should be considered in the future. Furthermore, we showed that in a Finnish population, using two different validated Finnish diet scores, we got quite different results. And when we compare this to the Mediterranean diet score, we got different results again. So maybe the application of this exposome score across populations may not be the most accurate, but the concept of a score itself may be suitable. As I mentioned, we did find some unique associations. So the exposome score may help identify which exposures contribute more. For example, we've seen that when we removed air pollution had quite a big impact on the results. So both looking at the impact of individual exposures, but also the role of the individual exposure in the overall exposome profile. While we didn't measure adiposity, we did look at weight status as a potential effect modifier. Now, while these individuals weren't necessarily living with obesity, they had a higher BMI versus a lower BMI. And it may be the case that the body is able to tolerate a certain level of unhealthy exposures. Some individuals living with a higher BMI can be healthy, just like some individuals with lower BMI can be unhealthy. And so it's just a case of trying to identify the threshold that an individual is able to tolerate before the risk of disease starts to increase when you look at the balance of healthy versus unhealthy exposures. And finally, approaches to improve the health status of the population should not be necessarily carried out in isolation or targeting just one thing, but should be looking at the overall effect of an individual's exposome to try have good increases across multiple parts of an individual's life rather than just trying to perfect one aspect of it. And so in different aspects of an individual that can be targeted include, governmental policies to reduce air pollution, but also trying to improve lifestyle exposure such as diet quality and sleep, and then seeing the impact of this on the overall individual's overall health profile. And that's the end of my talk. Thank you very much for listening.